transportation, a cornerstone necessity for nearly everyone. Throughout history, various means of meeting this need have been invented, from the primitive ones like bicycles to more elevated ones like helicopters. Despite the come and go of numerous trends in this sector, certain means of transportation manage to preserve their spot in today's society, thanks to their efficiency, one of which is, of course, trains.
Ever since its invention in 1804, trains have been a popularized mode of transportation, and we have built tons of train routes, connected cities that were hundreds of kilometers away from each other, and speeded up the travel time between those cities with trains. Throughout the 20th century, countless steps have been taken to improve the train industry, but among those, one completely changed the track of this industry, which is the invention of the first high-speed train in Japan in 1964. It is still operating under the name of Series Ohikari. Today, this train is considered to be the first Shinkansen, translating into bullet train in English or new trunk line in Japanese. This train held special importance because it reduced the time travel between Kyoto and Osaka to just 3 hours, setting the foundation for numerous prospective speed records. Being influenced by the remarkable qualities of Ohikari, train manufacturers started to fabricate its technology while also trying to improve the speed and safety of these new sprung high-speed trains. Slowly yet surely, new types of trains were developed, with the most revolutionary ones being the maglev trains, reaching jaw-dropping speeds like 470 kilometers per hour. Have you ever wondered about the working principle of those trains? Even when they first came out in 1964, they were able to travel 5 kilometers in just a mere minute, and now with the recent developments, they can travel twice as fast. The astounding physics principles enabling us to reach such high speeds will be explained in this video. If you're ready, let's begin. Let's start by exploring the fastest train in the world to truly comprehend the dimensions of high-speed trains. It is the almighty Japanese maglev train and is mostly known for beating the last peak record by managing to travel as fast as 602 kilometers per hour. Maglev trains reach such extreme speeds thanks to the principle of magnetic repulsion, a fundamental concept in physics. The main phenomenon that has been keeping traditional trains from reaching high speeds is high friction. However, maglev technology solved this problem by eliminating the source of high friction, that is, contact with the ground. In other words, maglev technology employs extremely powerful magnets to create levitation, making trains literally float in the air. A multi-component system called Electrodynamic Suspension System, or EDS, is used to create maglev trains, and rails for these trains are also a unique component of this system, because unlike regular rails, they have two sets of cross-connected metal coils shaped into a figure 8, enabling it to contain several electromagnets. The train itself also has superconducting electromagnets, or bogies, interacting with the electromagnets on the rail. This process is pulled off by the rubber wheels of the train, as the train first uses those wheels to let the magnets interact with each other, making the process a feasible and paramount effective one. It also enables the train to move forward while keeping the process safe and sound. Also, did you know that the word maglev itself comes from the words magnet and levitation? A very self-descriptive name it is.
In the future, we expect to see trains that can accelerate towards higher speed rates, rails that will make the destinations safer places to reach, and better engines to be able to support higher energy levels. As we wrap up this video, we would like to invite you to support our channel by liking this video and subscribing for more engaging content. Additionally, explore our website where you can access podcasts and articles. Thank you for joining us on this journey towards the future of trains.